Hello, in this session I'll show you how our 3D printers work, what's the technology, and workflow of our devices. We have a FDM device, this is one here. It works on the basis of fused deposition modeling technology. The other one is SLA, stereolithography. It works on that technique. So, let's focus first on the FDM 3D printer. So, this one functions on melting thermoplastic from nozzle to build platform. So, first what we have in this here device is this disc containing filament of material. Down here you can see some filaments we usually use for our purposes. It is PLA material, ABS material, PETG. This one is based on PET material, polyethylene, with 20% of carbon fiber added. Then, next one we have here is wrapped in this plastic for humidity reasons. This is a polycarbonate material used for higher temperature applications. Then, one interesting material we have here is HIPS. This is a polystyrene material used as a support structure for ABS material. This one dissolves in aluminum, so when you make a support structure from HIPS, you can take the model to aluminum to dissolve this support and leave just ABS printed material you need. So, let's get back to a workflow of this printer. It is already on. So first you have is this disc of material. This here is PLA. It is wrapped around this disc. I'll return it back. And from this disc, this filament goes right in a 3D printer. So this 3D printer has 5 stepper motors to work. It contains a Arduino platform for sending data to these stepper motors. We have 3 stepper motors for each axis. One stepper motor controls x-axis movement, second one y-axis, and the third controls z-axis movement. The other 2 stepper motors are used for movement of filament through the nozzle. So they push the material into the nozzle, and that's how a plastic goes from a nozzle to build platform. Then, on this picture you see an FDM 3D printer from inside. Here you see a complete console with 2 stepper motors, one for the left extruder and the second one for the right extruder. With 4 screws, they are connected with this metal block containing 2 pulleys, which are used as a mechanism for guiding the filament into the extruder. Below them you see an extruder. This is an extruder part containing a radiator, heated block and nozzle, and of course this vent which is mounted to a radiator part. You see as labeled as A filament from the outside. It goes right into this polyethylene tube, right into this metal block, to these 2 pulleys which guide in the filament right into a canal which is at the center of this radiator, right through it to a heated block. For PLA material, which we mostly use, we heat a heated block to 200 degrees Celsius. Maximum temperature of this here part is about 280 degrees Celsius. These heated blocks consist of these metal blocks which are connected with screws to a resistors which heat up this aluminium block to set temperature. Below them you have a nozzle from which a material, a filament, is extruded right onto a build platform. So you have a left extruder for one material and a right extruder for the other material. Here on the right side you see a glass cover for this metal block, and on the left side I've unscrewed the glass cover to show you how this pulley mechanism looks like. This pulley mechanism is controlled with this here screw, with which you define a contact of these 2 pulleys with a filament. If a screw is loose, there would be no contact between pulleys and a filament, so there would be no movement of filament into the canal. If the screw is over tightened, a material would rip a filament, causing a damage and failure. So a screw must be set at the best tightening. So you see here a connectors to a vent. So this here radiator prevents overheating, or prevents an influence of a heat from the heated block to a canal which is placed in this radiator. So radiator disperses heat from this heated block, and these ventilators have helped them in that job. Maybe just to mention the green color of the build platform. Build platform is mostly made of a ceramic material, but this build platform is covered with PET tape for best adhesion of part to build platform. So this is a menu screen of FDM 3D printer. Here on this first panel we see a temperature of a nozzle and temperature of a build platform. First one to the left is a achieved temperature, and the one to the right side is the temperature we set it for our 3D printer. So we see that they are matching. So nozzle conceived right temperature as well as build platform. This is a state of z-axis, which shows that it is in a first position. Next menu shows that our 3D printed nozzle is at the starting point. All values of x, y, and z axis are set to 0. Next, in the third menu, we have accept temperature of the first extruder and a build platform. We have a current temperature of the second extruder. We are now not working with the second extruder, so the temperature is not about 200 degrees, but still these 200 degrees slightly influence the second one. So now I'm pressing a button, so I'm entering a menu. Sorry for German language. This machine has only a German language package. So first is Zurich for back, then fast settings, schnell settings, then we have then from this here option we take files from SD card. The second one the next one is the one we use oftenly. This is a position button. Here we set a position of our 3D printer. Does it go to the first starting point of all axes, and particular point we want to set of the nozzle to build platform in X, Y, and Z axis. Then we have extruder position. If we want to extrude more plastic, we just type this button, and with this cursor we go right to left, meaning that we will extrude or retract filament from our nozzle. I'll leave it at 0. Now I'm going back. Next option is extruder. Here we set temperature of build platform, which is set at 60 degrees. Temperature 1 is at 200 degrees. Those are the best values for PLA material. The second extruder we are not using, so the value is set to 0. Then the working with first or the second extruder, default value is the first extruder. We are using the left one. So these are the settings I was mentioning now about the first and the second extruder using. And extruder position, we have like in the former menu bar, we have a same option here to extrude or retract material from nozzle. I'm returning back again. Next we have again from this here option, Druk Date, we can set a file we've already made for 3D print. I'll go back again. And next we have configuration. This is about our 3D printer. So I'll return back to SD card and I'll set a made file for 3D print, and I'll just press OK. It will start at 200 degrees and 60 degrees of build platform. So it now already starts before because we set the temperature before. So the printed has started. The left nozzle is extruding plastic onto a build platform. First thing that nozzle did was making a skirt around a 3D print. Now it prints a raft. So heaters are underneath build platform, so that's how it conceives 60 degrees Celsius. The nozzle is set at 200 degrees. So now we can see a 3D printing in motion. We see that nozzle on the left side extrudes material onto a build platform. First, a skirt was printed around a printed model, and what you see now is the first layer of the raft. Till the nozzle finishes the first layer, next thing what 3D printer does is that nozzle goes to a first position on the XY plane. Then, using these guides, one on your right side, one on the left, and there is one at the back, it conceives a pushing down of a platform for just one layer, and that's when a next layer begins. So after pushing down a build platform for a thickness of one layer, nozzle will print another layer, and another one, and another one, till the 3D printed model is complete. That's it. Now you can see a top view of our 3D printer. You see that the nozzles are connected to a console here, and it is moved by these steel profiles for Y and X-axis. Before I've shown you the guides for the Z-axis, so all of these profiles and guides make a pathways for nozzle movement. Now what I'm about to show you are these places here, one beneath, and there is one on the bottom of a 3D printer. Those are optic sensors. The only position that this 3D printer senses is the first position. When I'm setting a home position for X, Y, and Z axis, that is their zero position. A console goes to the origin position using these guides to those places, to places at the beginning where you have an optical sensor. When console exceeds those positions, optical sensor sees the first position, and it sends to a control panel that the position is 0, and you can continue with your work. Now, you see a greater view of our build platform. You notice this green color. That's a PET cover. It is best to use it because it conceives better adhesion of 3D prints to build platform. Also, just to point out the stepper motors, you see this one here, black thing with coils. That is a stepper motor for Y-axis, and these one for a X-axis. All of these elements contain bearings for longer lasting of a 3D printer. device I'll show you is a SLA 3D printer. So we have here a PC connected to our 3D printer. I've already opened a 3D printer software, and I'm about to upload a 3D printing job. So I'm clicking on a Start to Print button. Now it asks me for job file name and gives me information about my material. Is there enough material for 3D print, and does a 3D printer contain a tank? So I'll upload the job, just clicking one button, and now it will start uploading file to our 3D printer. Yes. So now the file is uploaded on our 3D printer. We can see it by looking at a desktop of this device. More so, from this here device, from its desktop, you can see does the 3D printer contain a resin tank in it, cartridge, what's the temperature of our 3D printer, and other settings like printer leveling. For this here technology, you have to level your 3D printer, and for that purpose, electronics here provide you a notice of leveling of your 3D printer. You use certain tools to fix the legs, all four legs of the 3D printer, for the printer to be leveled. Returning back, settings. And now, let's show you how this 3D printer looks like. Inside you have an UV laser and a vacuum chamber right underneath this panel. So from this here vacuum chamber containing two windows, it guides a laser beam toward the upper surface. So, to show you a closer look at a vacuum chamber, I'm opening the cover, unlocking the platform, and I am about to take the tank. So, here we have a glass on the top of the vacuum chamber. That is what I was talking about here. I can see, maybe you can't, two mirrors that I was talking about. So the laser beam is pointed at the top surface onto this here glass. This glass must be clean at any time. So after that glass, laser beam goes to the lower surface of this here tank. So I'm returning back a tank. Just to point out, this here is a contact for this tank containing a chip. That's how a 3D printer knows which tank I'm inserting with which resin material. So this here 3D printer uses thermoset plastics in a liquid form. Now you see that the tank is inserted, grade B4. So chip showed which type of resin we have inserted. So I'm now returning this wiper. This wiper, what it does, it wipes from left to right this plastic, remaining homogeneous form of this liquid. I'm returning it back. Just a second. Just a second, I have little spilling. Okay. So I'm returning back a wiper. And I'm returning back a platform. This is a platform where you'll have your printed sample on. So it is inserted at the top. This is a front side, and this is a Viper side. This is a Viper. So when a layer is finished, platform goes up, and a Viper does its left to right movement, swiping a material. So I'm returning this back and using this lock to secure the platform. Next thing I'll show you is a cartridge. This is where we contain our material. So it is a plain box with a vent on the top. So when I'm printing, I'm opening the vent for the airflow. When I'm about to finish and the printer will not work anymore, I'm closing a vent. So I leave it on. Material goes to this here rubber. This is when material wants to fill in material. It uses sort of a pinch mechanism to squeeze this rubber, leaving it open for plastic to flow to the tank. So I'm now returning our cartridge. And just to mention that our tank has this here extension where resin from cartridge fills in the tank. Now, just to point out how a platform goes up and down, that's the only movement it has. It has this guide here, and at the lower end of this guide you have a stepper motor which controls the movement of this here platform. Another thing to mention is this cover. This because our resin material polymerizes, and that's how we get solid objects. This cover gives us a security that no UV light from the outer source will influence the liquid stored in our 3D printer. And of course, if you have any spillings of liquid, if Viper goes more in such a manner that some material would spill, or your 3D print would come out from a platform, causing a splash in the liquid from this here tank. Just I'll return the Viper. Okay, you have guiding channels here for excessive liquid, and this channel goes right in here where you have a small chamber where all the spilled liquid will be. So I'm using this as a tool for getting that liquid from 3D printer. So 3D print file is already uploaded to a 3D printer, and now it asks us to print now this data. I clicked OK. Now it asks us to check, is the cartridge vent open? It is. And if the build platform is in place, that's one right here. And we have to confirm this with a press of a button. Now, Viper goes to the first position, build platform goes slightly down, and now we are waiting for procedure of filling and heating of plastic to be performed. We are waiting on filling. because the heating should be at least at 31 degrees. Now it's 22.9, so the temperature is right. We're just waiting on plastic to be filled in the tank. You heard this motion, and with a slight zoom, you may see how a 3D printer fills in the liquid into this here place. You'll see how a 3D printer inserts plastic from cartridge into a tank. Now you see the display when 3D printing has started. You see the time remaining to accomplishment of a 3D print, and as a visualization of that process you see this here blue circle. This white circle inside shows the completion of each layer, and on the top you see how many layers are conceived and how many you should have. So we are on the first layer, and there are about to be 2372 layers remaining. Now the build platform has lowered down into a liquid, just with a slight gap of 1 layer thickness between the lower surface of the tank and the build platform surface, so it leaves space for a layer to be polymerized. When layer is finished, a build platform will go up, a wiper would swipe from left to right, and the build platform will go again down for the next layer, also leaving a gap for 1 layer to be polymerized. And it will continue until the last 2372nd layer has finished. So here are some materials we use for SLA 3D printing. These 3 are standard resins, just differing in color. This is white resin. Here you see we have printed some dental models with it. This is the one, the tank for white resin. Gray one may be more suitable for making dental models than the white resin. Here is a tank of the material. As you see, color is the same. And the black one, here you see. Next are special resins. This one is called model resin, suitable for making accurate models. Something like dental models. You see the level of detail is greatly better than standard resin material. Okay, and now to show you the stars of the show, some biocompatible materials which are used for connection with the tissue. So here you see a so-called dental LT resin for aligners, for teeth aligners. Here is the material. It is transparent, as you see. And a material suitable for making surgical guides in dental practice. This one is also a transparent material with slightly green texture. After each print, what you have to do is you soak a material into a isopropyl alcohol to clean a model, and after that you use a UV lamp to cure more the 3D printed material to achieve such look. So now the 3D printing is done. I'm opening a door. Here are our prints. 5 tensile testing specimens and 3 card holders that resemble a CT specimen. They all have rafts which we have to cut from them, leaving only the part. Okay. Now let's see the SLA 3D printer. is finished as well. So the 3D printer asks us whether the 3D print was a success or failure. We'll click on success. I'm opening the cover and opening the lock too, and now taking the platform. And this is how a 3D print from SLA 3D printer looks like. So you see a raft on the bottom of build platform and a structure of support for 3D print. Here is a tensile testing specimen and a card holder looking like a compact tension specimen, all covered with supports. Next thing, what I have to do about this SLA 3D print, I'll have to soak it in the isopropyl alcohol to release all the liquid resin from the 3D print. So for that case, I use these two so I'm taking a specimen in the alcohol and the other one with the spatula. Sorry. I'll use another tool. So I'll leave the 3D prints in alcohol for about 15 to 20 minutes here, and then I'll set them to the next alcohol, and after that we'll have finished prints. Tensile testing looks like. Finish in SLA 3D print is far better than the FDM one. The dimensional accuracy is far greater than one on FDM. So with a CT specimen card holder. This is one from FDM 3D printer, and this one was conceived with an SLA device. Finish is far smoother than on the FDM one, which feels rough to the touch. And of course, certain details like circular patterns are printed with far greater precision. And you see the initials of our institution, Innovative Center of Mechanical Faculty. The words are better printed with an SLA technology. That's it. And after a soaking in isopropyl alcohol, SLA 3D prints are then cured in a UV light chamber for a couple of minutes. So the card holder on FDM 3D printer is finished. Now we'll look at the UV lamp for SLA print, and this is how same print files look with different 3D printing technologies. This one is SLA and this one is FDM.